Welcome back to section 5 of chapter P. This section we're going to be looking at solving equations, which is again one of those things that you've been doing for years and years and years. And so this will, generally speaking, be review. Again, there might be little snippets of information in there that are new or forgotten, but for the most part, this should be a pretty quick and easy thing. So we are going to be looking at solving equations graphically, numerically, and algebraically, which is also the title of our book, notice. Not solving equations, but the graphically, numerically, and algebraically. So our learning targets for today. We can solve equations graphically. And that's generally using a graphing calculator. It is not the best way to solve equations because it just gives us an estimate. But there are times when solving it algebraically is either amazingly difficult or not possible with what you know to this point in time. So being able to solve something graphically or even just to get an estimation of that is an important skill. Solve quadratic equations by extracting square roots. That would be by using square roots. We'll see that it's a weird way of saying something that you already know how to do, most likely. Solve quadratic equations by completing the square. Those are those couple words, those three words that everyone loves to hear, completing the square. We'll do a quick review of that as well. Solve quadratic equations using the quadratic formula. If you haven't, if you still remember the quadratic formula, awesome. If you have momentarily forgotten, that'll be a great review. And then solve equations by any method. That would just be using some of those. So, solving equations graphically. If we have an equation, we need to graph it. So, in order to graph something like this, what we would do is we would want to set it equal to 0. Is one of the methods. That's the method I would select for this particular thing. I'll show you another method later on, but let's set it equal to 0. We subtract 2. So we end up with 3x. Subtract 2, we get plus 5 equals 0. And then this equations graph that popped up, because I didn't have a color selected, so when I put my pen on it, it clicked to the next thing. That isn't 3x plus 5 equals 0, because when you enter something into the graph, it has to be y equals something. And so we make it y equals 3x plus 5. We're just looking for when does y equal 0. There. It equals 0 right there. When x is at about negative 1 2/3, it looks like. Again, that's an estimate. Like when it crosses at a perfect spot, that's still an estimate. It's less of an estimate, but it is still an estimate. But in this case, we have it's when x equals negative 1 2/3, which would be negative 5/3, which, as we're looking, like, this is not a hard equation to solve algebraically. And so as we look at it, it's like, yeah, negative 5/3 makes sense. Why did I even use it? I use it just to show you the idea of solving graphically. We're looking for the x-intercept there. A different one, a quadratic equation. Quadratics are ones where all of a sudden solving it graphically makes a little bit more sense. We would again do the same thing. The other option, we could set each of these equal to y, and then instead of looking for the intercept, we'd be looking for when the two lines cross each other. But generally speaking, making it x squared plus 2, or x plus 2 squared minus 16 equals 0, and then just making it y equals that, x plus 2 squared minus 16. You don't have to distribute it out. It can be just right there. We can graph that to get the quadratic. If we zoomed out, we would see the bottom part of the quadratic there. But we don't really care what that is. We're looking for when does it equal 0? It equals 0 at those two places. So at x equals 1, 2, 3, 4, 5, 6, negative 6, and 2. So at x equals negative 6 and x equals 2. Notice the answer is not negative 6 and 2, it's x equals. I've said it before and I'll probably say it some more. When you start out with an equal sign, your answer needs to have an equal sign. So that's the idea of solving equations graphically. Now, solving quadratic equations non-graphically, there's a few things we can do. We could use square roots. Using square roots, starting out with the same question that we were looking at in that last graph, let's see how we could do it graphically. So we have the x plus 2 squared equals 16. We have something squared equals a number. Take the square root of both sides. When we do that, we now have x plus 2 equals plus or minus 4. Because when we square root both sides, we could have a positive or we could have the negative, because both of them square to get that positive 16. And so then we just split it into two. We have x plus 2 equals 4, x plus 2 equals negative 4. And we solve each of those. Subtract 2, x equals 2, subtract 2, x equals negative 6. Hey, that's what we saw when we were looking at the graph and got our estimate. So using square roots, that would be the extracting the square roots that we saw. It's just, you get it so that it's something squared equals a number, root both sides, which means plus or minus, and then solve from there. So we have that. We have completing the square. In completing the square, we do a process. Now this one, it's going to come out nice. You might think, wait, I can factor this. This is going to be x minus 5 times x plus 1. Yes, factoring is another great way of solving quadratics. That's the way that people remember, though. We're not going to focus on that too much. But yes, if you can factor it, that is a fantastic way to solve quadratics. We're going to complete the square with this so we can see the process with a problem where the numbers are going to work out kind of nice. So the completing the square process, which is different, like I'm going to show you a different way than if you look in the book. The book's way is also good. I'm not saying it's not. It's the same thing. My process is a little bit different. It makes a little bit more sense to me to do my process, but if you know another way of completing the square or the book's formula is perfect for you, go with that. The way I do it is we're going to get the x, all the x's on one side, the numbers on the other side. So we have the x squared minus 4x, and then we're going to add the 5 over, so it's going to equal 5. Now I left a space there because something's going to go there. Now the x squared has to be by itself. If we add a number in front, we'd have to get rid of that number. We'll see what that looks like actually in the next example. But the x squared's by itself, so we're ready to complete the square. So the next one, we're going to have something squared. The x goes right here. This other number, this negative 4, we need to divide by 2. Negative 4 divided by 2 is minus 2. We then square that number, and that gets added up here. So negative 2 squared is plus 4. Notice that will always be a positive, because when we square it, it'll be a positive. So now, if we factored this x squared minus 4x plus 4, we would get x minus 2 squared. The problem is we can't just go adding 4 to an equation whenever we feel like it. We have to do it the same thing to the other side. So we add 4 over there as well. And now 5 plus 4 is 9. So we took that number, we divided by 2 to get inside the parentheses. We squared it to get the number on top, and then we had to add the same thing to the other side. That's my process for completing the square. Now we can solve this. It's something squared equals a number. So we could square root both sides. x minus 2 equals plus or minus 3, which means x minus 2 equals 3, x minus 2 equals negative 3. Add 2, x equals 5, x equals negative 1. So we have 5 and negative 1, which, if we think back to factoring it, that's the same thing we would have gotten. All right, let's do one that's a little bit tougher here. We're going to complete the square. It's a little bit covered up there. I'm going to erase just a little bit here. Just this solution, not that it's a bad solution, just so that we can see that. I used a little bit too much room. So this quadratic equation is definitely bigger and more obnoxious, but it's still just a quadratic equation. We just have some work to do beforehand. So we're going to work on simplifying and combining like terms. So on the first side, 3x squared minus 6x minus 7, there's nothing going on here. Really what we're looking at is we've got this that needs to be distributed. So we have 3x squared minus 6x minus 7 equals x squared plus 3x. Now this is a whole negative x, so minus x squared minus x plus 3. Combine our like terms. 3x squared minus 6x minus 7 equals x squared minus x squared. Oh, that's cancel out. 3x minus x will be a 2x plus 3. Now we want all the x's on one side and the numbers on the other. So we'll subtract the 2x, gives us 3x squared minus 8x, and then add the 7, so that'll equal 10. So notice I left my space. So now we're at this place, and this one has a lot of everything that could make up the completing the square hard. We have a 3x squared. We don't want 3x squared, we need x squared. So we can factor out the 3. There are certain situations where you could divide everything by 3. This is one of those. You could do it that way. I'm going to show you the factor out because that will work in every situation. So we factor out this 3. And so we have x squared minus, you might think, wait a second, 3 is not a factor of 8. So minus 8/3. X, leave the space, equals 10. Now we're ready to complete the square. This 3 is still there. We're going to have something squared equals something. This beginning is always just x. We always start out with x squared. It will always be x. Now the second number, we divide by 2. What's 8/3 divided by 2? Negative 4/3. And then we have to square that. 4/3 squared, remember with a fraction, and you square it. You square the top, you square the bottom. So this will be plus 16/9. Since we added something there, we have to add something to the other side. Now the trick is, we did not just add 16/9 to that side of the equation. We added 16/9 times 3. So that's what we have to add to the other side of the equation as well. 16/9 times 3 is going to be 16/3. So we have 10 plus 16/3 that we have. Well, 10 is going to be 30/3 plus 16/3 is 46/3. Now we can continue solving. We almost have something squared equals a number. Now we could divide by that 3 to get x minus 4/3 squared equals 46/9. Square root both sides. We get, I'm going to move it up here a little bit. We get x minus 4/3 equals, what's the square root of 46? square root of 46, plus or minus. Over the square root of 9 is just 3. Now we can add the 4/3. So x equals 4/3 plus or minus the square root of 46/3. There we go. That would be solving completing the square. And again, that problem has all the things that could make it hard. It has first of all, we had all the stuff we had to combine before we even got to completing the square. But even at that point, we had to pull out the 3. 3 didn't go into 8, so we ended up with that fraction there. And so everything that could go wrong in a completing the square problem is right there. And yeah, it took a bit more space, it took a bit more time, but it's still not that hard of a process. You just have to deal with fractions and stuff. The other way is using the quadratic formula. Now the quadratic formula is actually completing the square. If we completed the square with ax squared plus bx plus c equals 0, we would get x equals negative b plus or minus the square root of b squared minus 4ac over 2a. Like that comes directly from completing the square. So as opposed to having to go through the steps every single time, we could just plug stuff into the formula. So if we use the same equation, we could plug stuff in. A is 1, b is negative 4, c is negative 5. So we just plug it in. X equals negative b, so that would be 4, plus or minus the square root of b squared, 16, minus 4 times 1 times negative 5, all over 2 times 1. Simplify. See, the quadratic formula, it doesn't take thought, it takes computations, whereas factoring takes thought. But the quadratic, I mean, there's no thought, but the computations can be long and obnoxious. So we have 4 plus or minus the square root of 16, and then negative 4 times 1 times 5 is 20, so plus 20 over 2. X equals 4 plus or minus the square root of 36 over 2. X equals 4 plus or minus 6 over 2. And so x equals 4 plus 6 is 10, divided by 2 is 5. Or 4 minus 6 is negative 2, divided by 2 is negative 1. Notice that's the same thing we got from completing the square. It's the same thing we would have gotten by factoring. So that's using the quadratic formula. Now solving absolute value equations is a little bit different because you're going to have to split it up. An absolute value is kind of like a quadratic, where you can have 2 solutions or 1 solution. Now we won't have absolute values of quadratic. They're going to be linear absolute value equations, or you're going to be solving by graphing. So to solve something like this by graphing, we have the absolute value of x plus 1 equals 4. We are going to type it in. And this is where we could type in each side separately. Yes, we could have subtracted the 4 and had the absolute value of x plus 1 and then minus 4 equals 0 and plug it in, look for when does it equal 0. Or we could do it this way. We've typed it in, we have absolute value of x plus 1 and 4, and when we graph, we get those two, and we're looking for where they intersect. So we're looking for here and here. So what x values are those? That looks like x equals 3 and x equals negative 1, 2, 3, 4, 5. So it looks like x equals 3 and negative 5. We can solve this algebraically as well. The absolute value of x plus 1 equals 4. So like a quadratic, you'd get it down to just the absolute value by itself, just like we got it down to something squared, and then we'd square root. Well, here we have it down to the absolute value, and then we don't square root, but what would give us an absolute value, like what would give us an absolute value of 4? Well, it could be 4, so x plus 1 could equal 4. Or x plus 1 could equal negative 4. So it's kind of like the square rooting, except we don't change the number, we just do get both signs. We get the plus and minus. So x plus 1 equals 4, we subtract. X equals 3. X plus 1 equals negative 4, subtract. X equals negative 5. So that's how we could do it by hand, or algebraically. Looking for the this one, it's a little bit different because we have an absolute value on both sides. This is one where trying to do it algebraically is a bit more difficult because you have plus or minuses on both sides, and it's kind of weird. Not impossible, but it is kind of weird. When you have multiple absolute values, that's usually a good indication on, let's just graph this. And so in this case, this is one where you would probably want to do y1 is absolute value of x plus 5. And if you're using your TI, like I did for these, the absolute value is in the math menu. Then you go over to number. It's that very top one. It's abs. If you're using the Desmos, in the graphing calculator, down in the bottom left-hand corner is the little keypad, and the absolute value option is just right there for you. But y1 would be absolute value of x plus 5. y2 is going to be the absolute value of x minus 3. And we graph that, and we get that graph, and we're looking for where they intersect. These two will only intersect this one place at x equals negative 1. Now it's always a good idea to plug it in, see if it makes sense. Negative 1 plus 5 is 4, absolute value is 4. Negative 1 minus 3 is negative 4, absolute value is 4. This checks out. And that's the only place you can see that these are going to be parallel, so they won't intersect again. So that is looking at solving equations using graphs and algebra, and numerically would be just using the intersect feature, the 0 feature on a calculator. So it's using that technology to do it. But this is what we're working on. I will see you in class, but until then, keep asking questions, keep working problems, and as always, happy mathing.